The previous question, we used our equilibrium conditions to determine that our force of friction to prevent this thing from accelerating had to be 69.3. And if you recall, we used the horizontal condition that the sum of all the forces horizontally, which I'm calling the x direction, has to add to 0. So we used that, we got our friction forces to be 69.3. Now this is a continuation on it, and they want you to calculate the coefficient of friction. Well, if you recall, our formula for force of friction is the coefficient times the normal force. We're trying to find out what mu is. So if I solve this for mu, the coefficient of friction, I get mu is equal to force of friction over Fn. Now we know the force of friction, we just have to figure out what Fn is. So Fn is a vertical vector. So now we've got to focus on the vertical direction. And fortunately for us, it's the same set of rules. It's still not moving vertically. So the sum of all our forces in the y has to add up to 0. So the most common mistake with this question is that people want to put Fn is equal to 196 so they cancel each other off. But remember, the normal force is a squeeze. And I'm pushing down slightly with this 80 Newton force. So I'm giving it an extra squeeze downwards of Py. So you remember this little blue vector here is in the downward direction. It's an arrow pointed down. So we're trying to figure out what that extra little push is so I can add it to 196. Now if you want to use our sum of forces equal to 0, which I prefer, let's use our diagram. Let's say any force that's up is positive. So Fn is positive, and any force that's down is negative. And you can see that my Py is pointed down because this vector is below the horizontal. So minus Py minus W all has to add to 0. Now how do I figure out Py? Well, if you look at my little triangle here, I know the angle down here is 30 degrees. It's got a little cluttery on the picture. I appreciate that, but you can see the 30 up here. Py is opposite, and we know the hypotenuse. So we're going to use sine. Sine 30 degrees is opposite over hypotenuse, and I solve it for Py. Py is 80. Sine 30, Py is 40 newtons. So we know Py, we know W, we know everything. We can solve for Fn. My Fn will be equal to, when I bring all of this stuff over to the right-hand side, will be equal to W plus Py, which makes sense. It's got to be bigger because there's a bit extra squeeze. There's a 40 Newton extra on the squeeze. So we end up getting a normal force of 236 newtons. And now I can finish my question. Okay, let's use yellow again so we can see it. Mu is force of friction divided by Fn. We figured out the force of friction in the previous question, 69.3. Fn we just figured out to be 236 newtons. And you end up getting a coefficient when rounded off to 2 sig figs of 0.29.